Today, CERN announced the discovery of the Higgs boson particle. So what does that mean? This is the particle that is responsible for breaking the symmetry in our universe to give us the forces we see. And this is perhaps the most momentous day in particle physics of the century. So the mathematical structures behind electromagnetism, the weak force, and the strong force all came together in the 1970s in what's called the Standard Model. But according to these theories, these particles shouldn't have any masses. So the Higgs is the missing link that provides a description of how all particles get their masses and how they interact with the gravitational field. The Higgs boson has been the holy grail of particle physicists for the past many decades. But still, since the 70s, it's only been a theoretical construct. We've been trying to get evidence for the existence of this Higgs boson for decades now. And we threw in with Europe and an international collaboration to build the Large Hadron Collider in Geneva. It's like the most enormous machine shop you've ever seen. And beneath this machine shop, you have a 17-mile circumference ring, which is the ring in which you accelerate protons in opposite direction and bring them in to collide inside these absolute enormous detectors that are the size of a battleship. The mass of the Higgs is extraordinarily large. And this is why other particle accelerators until now weren't able to see it. In order to get enough energy to pop one of these Higgs bosons into existence, you have to take other elementary particles and collide them with extraordinary amounts of energy. So you think of a proton, it's hardly substantial at all. But one of these protons is coming in near the speed of light, and it has as much energy as the kinetic energy of a flying mosquito. After this collision of protons, for this brief moment, you have this intense burst of energy. The Higgs is created and flies out in some direction. And then it decays into other particles, and those spread out and decay further. And then they hit a huge bank of detectors that surrounds the collision point. And from the signal in the detectors, we're able to reconstruct what the paths were of these elementary particles and what their properties were and where they came from, and know that there was a Higgs boson right back there at that point. So we have the Higgs. What's that mean? Now what? Well, what it means is something very fundamental about our understanding of the universe. We know that the universe came into existence as the breaking of this more perfect mathematical structure. So it's almost never clear what implications a new fundamental discovery in physics is going to have down the line in terms of engineering and what you can produce of practical benefit for society. But there always is one. It was Rutherford did the first experiments with colliding other particles at higher energy into atoms going inside through the electron shell and actually colliding with the nucleus. And this was purely basic science endeavor. But it turned out these physical discoveries, this description of atoms, had enormous implications. It led to the development of the atomic bomb and atomic fission for power generation. And then understanding this allowed us then to also create nuclear fusion. Now that we know the existence of the Higgs boson, this is just as significant as finding out that, in fact, atoms do have these hard little nuclei. As basic science, it's as fundamental of a piece. And we don't know what the implications will be decades down the line for this discovery, but they will surely be huge. But we have no way of knowing what that's going to be until we get there. Same way as Rutherford couldn't have foreseen nuclear reactors. I mean, for me, it's just fantastic to find out how the universe works. But the practical applications, how are people going to make money off of it? Well, it's like, well, how much money do people make off the internet? And that came about because of a CERN researcher, Tim Berners-Lee, who invented the World Wide Web, trying to figure out how to better communicate among physicists at CERN. So there are lots of spin-offs. One of the things I deeply felt while at CERN was the strength of the collaboration that it took to achieve this. At CERN, you have thousands of physicists from all over the world working at this same goal of finding out what the fundamental building blocks of nature are. And to have everybody from around the world working on this project, it was one of the most intense things I've ever seen. It's an amazing achievement from a long, arduous, and worthwhile endeavor, and I'm looking forward to seeing where particle physics progresses from here.